Hello, welcome to the Satellite Marketcast podcast, where we feature key executives from leading satellite companies worldwide, talk about their company, their careers, industry trends, and other insights on the exciting satellite communication industry. I'm your host, Virgil Labrador, Editor-in-Chief of Satellite Markets and Research, inviting you to another informative podcast with our featured guest today. Well, welcome everybody to this edition of the Satellite Markets podcast with our guest today, Carl Novello. He's the CTO of a company called NXTCOMM. Carl has been in the industry for a good while. He's worked in many different companies, including Intellian and Kymeta, before joining NXTCOMM just early this year, actually, just a few months ago. So prior to joining NXTCOMM, Carl served as Vice President of Solutions for Kymeta Corporation, where he led the design of the company's flat panel ESA antennas for the mobile marketplace. And before that, he was Vice President of Products and Product Management at Intellian Technologies, where he led the development of Intellian's tri-band multi-orbit maritime VSAT antenna that won the Satellite Technology of the Year award presented during the Satellite 2019 show. So, Carl, welcome to this podcast.
Virgil, thank you for having me. It's always a pleasure to speak with you and your audience.
And likewise, Carl. And as I said in the introduction, you've worked with some leading-edge companies in the industry, and your career almost parallels the development of this comms on the move segment. You worked in Intellian, where you specialized in the maritime application for comms on the move, and you worked on aero solutions, and then we're looking forward to your talking about this new company that you've joined. But first of all, just lay it out for us, Carl. Give us an overview of the state of the satellite mobile market and how the global pandemic has affected it.
If you would have asked me this question a few months previous, I would have given you a much rosier answer. When we look at the mobility sector, it's been hit significantly hard by the pandemic. I mean, I feel foolish for saying this because it sounds as if I'm stating the obvious and apparent. But if you look at the mobility sectors and the traditional maritime and broadband VSAT categories, right? You have them dominated by the aviation industry and the maritime markets, in particular the high value markets, such as the cruise industry or the oil and offshore markets. And it comes as no surprise. If we look at the aeronautical market and the aviation industry, hey, people aren't flying. And if people aren't flying, the revenue generation isn't there. So demand isn't going to be rosy for connectivity services either because of this pandemic.
Right.
And that flows down through all of the others. So in the last 6 to 8 months, what have we seen? We've seen a decided slowdown in those particular markets. But the important thing to realize is that the fundamentals, the drivers for communications and connectivity across the mobility market aren't changing, right? So while it's easy to focus on the gloom and doom of nobody's traveling or oil prices are low or nobody wants to think about getting on a cruise for fun, right? The underlying fundamentals are still positive as it relates to the drivers for the satellite mobility market. And that's the light at the end of the tunnel.
Right. And actually what you just said, Carl, is borne by the research. The NSR and other research companies have come out with projections that the aero market and the maritime market, as you said, is fundamentally sound, but it may take a while. It could take a couple of years for it to get back where it was. So in the meantime, do you see any other opportunities or any other market segments, at least replacing that for your segment, the comms on the move mobility market?
Yeah, well, while it will take some time for the traditional mobility market segments to recover, right? I expect there will be some good growth in particular, the on-the-move use cases as it relates to the defense and government, as well as potentially first responder solutions. So we expect some growth there in the near term.
Right.
And that'll be interesting because that'll move us a little bit from where we've been focused on the market, and let's face it, where the numbers are more compelling, right? And moving that on towards land.
Right. Now, I know you're an engineer at heart, Carl. You're the CTO, and your focus is really developing the technology. Now, for the benefit of our readers who are not engineers, they probably work in the industry, but in marketing or other jobs in the industry. Give us a brief kind of tutorial of comms on the move. The parabolic antenna, the dish, as we call it, has been dominating the industry for many, well, since the beginning and till now. Now, you work on, in all the companies that you've worked at, you've worked with on these flat panel antennas, which has been around for actually since the 50s, but it hasn't really taken off commercially.
Yes.
So talk about that part of this.
So first things first, if you're okay with this, Virgil, I'll talk about the challenge of mobility and explain what that looks like with a parabolic.
Right.
So when you're underway, when you're in motion, right, that means your satellite antenna itself has to repoint and keep tracking on the satellite.
Right.
When you think of the satellite dish we all have in our heads, the TV receive antenna that you see on the side of everybody's houses, right? The direct TV or the dish network antenna, right?
Right.
Think of taking that same parabolic and having to, while you're driving down the street, keep that pointed to one fixed place in space while I'm driving left and right and so on and so forth.
Right.
That's a difficult challenge. So we've come to do this just the way we've done for a number of years, relying on motors and sensors.
Right.
And that's a fantastic solution for many, many markets, right? Fantastic solution for the maritime market where you have the space. Fantastic solution for the aviation market. That's how we've built up and addressed the markets today. But what's the difficulty there? The difficulty is when you have these mechanical systems with a parabolic, they're relatively heavy, right? Because I need motors to move it. And if I need motors to move it, I need a structure, right? And if I have a structure and motors, then I'm heavy. Right? And then the other side is, not only am I heavy, I'm relatively large. So in the geostationary arc, motorized parabolics work out relatively well. But what happens when this new era of space innovation comes to the forefront, where these LEO constellations, regardless of whether they're called SpaceX or Telesat or Amazon's Kuiper or whichever one may be down on the concept stage now, that's coming to a reality tomorrow. In a LEO, your satellites are moving with reference to where you are on the Earth. So if the satellite's moving with reference to where you are on the Earth as well, it's not just that you need to track to a fixed point in space, but you need to track to a moving point in space. And then what happens when you can no longer see the first LEO satellite? That's the challenge of make before break.
Right.
So to do this in a standard parabolic approach, you'd need multiple antennas.
Right.
And realistically, how difficult is it to address, say, on an airplane, multiple parabolic antennas?
Right.
There's just not the room.
Right. So one flat panel antenna can replace several parabolic antennas, basically. But the challenge is it has to, well, their size, the weight, and that very tricky thing, called the price. So,
Yes.
how are you
Yeah.
how are you confronting those challenges to get your products in the market?
Yeah. So one of the big challenges or hurdles with existing and previous style flat panel antennas of all sorts,
Mhm.
is exactly as you said. They've been expensive.
Mhm.
They've been expensive. And generally speaking, when you're looking at inventing a brand new technology, right?
Mhm.
That's always the expensive part of the curve. So what we've done on the NXTCOMM side is we've innovated the part facing the satellite and the flat panel, what we refer to as the radiating element.
Mm-hmm.
So by innovating the radiating elements, by building a more efficient antenna aperture, right, we can reduce cost.
Mm-hmm.
That cost reduction isn't just because of the RF design, but it's the design for manufacturability.
Mm-hmm.
At the end of the day, the design that we're implementing, our technology, is based on a printed circuit board approach. So replacing the mechanically steered antenna or with a parabolic or some of these other flat panel approaches with esoteric and exotic materials,
Right.
with something that all of us use every single day in our daily lives. Electronics built on a printed circuit board. And that's been one of the challenges for our industry as it relates to flat panel antennas is how do we scale, right?
Right.
How do we build things at a price point for large volumes?
Right.
Every single one of us, Virgil, now I'm going to feel old a little bit. Going back to my ComSat days.
Mm-hmm.
When I first started in this industry, mobile phones, I know it's going to shock people, wasn't something everybody had in their pockets.
Oh, yeah.
So think of the huge step change. I remember ignoring the bag phones and the Motorola brick phone,
Mm-hmm.
but in what I first thought of as mass market mobile phone, right?
Right.
Was my Motorola StarTAC.
Right.
Now that's been replaced with an all singing, all dancing, all knowing Google product in my pocket that can tell me anything.
Right. Right.
What we kind of forget about is that change has only happened in the last 12 years, 13 years.
Right. 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 And do you see that happening in the satellite
I say this
industry,
because,
Carl? Because the mobile phone it has a kind of a larger market. Everybody has a phone now. Billions. So they really had
absolutely.
they have
And
the
this is,
investment. They have the market to grow in. So is the satellite market able to make that great leap?
yeah, and this is my big hope for the future in the satellite market and our industry.
Mm-hmm.
Is look at the amount of money in these new conceptualized constellations.
Right.
Right? They're only doing this, they're only investing this because they're trying to solve big problems. And that big problem is, how do I connect more and more people on the planet?
Mm-hmm.
Right? And some of these satellite constellations have the potential to move us from being the last mile of the last resort, right?
Mm-hmm. Right.
To being a preferred carrier. Like, think of it. The promise of a satellite is that with a single satellite in the sky, regardless of whether it's a LEO, a MEO, a GEO, doesn't matter, I can cover a huge geographic area.
Mm-hmm.
Right? That's the fundamental value proposition of a satellite. Hasn't changed since Arthur C. Clarke and extraterrestrial relays, right?
Right.
Move the radio tower somewhere really, really far away in space, and you cover more people.
Mm-hmm.
Well, now finally, when you're talking about these mega constellations, right?
Mm-hmm.
There comes an inflection point where, hey, it's better to put I'm going to use a bad example. I'm going to call it the cell tower. It's
Mm-hmm.
better to put the cell tower in the sky than on the ground.
Right.
And that's the big step change for us. This is why I'm so excited about where we are as an industry,
Mm-hmm.
right? Because this is the exciting part. Hey guys, we've got finally constellations in the works, right?
Mm-hmm. Mm-hmm.
That can support not just my old way of thinking of it, where broadband was 64 kilobits per second, right?
Mm-hmm.
And scale users were 200 mobility sites floating around the world.
Mm-hmm.
But literally supporting gigabits per second, terabits in capacity, in constellation capacity, right?
Right.
Supporting hundreds of thousands, if not millions of users.
Right. Right.
And that's very, very exciting. But
right.
we only get there when the constellation side of it, the satellite network side of it, the ground infrastructure side of it, and the user terminal side of this all converge.
Right.
I'm going to make a statement that sounds absolutely ridiculous. I'm warning you.
Mm-hmm.
So, in that respect, trying to find the points of conversion, the coronavirus pandemic has been a benefit to us as an industry. And the obvious reason why is, because everybody's hooked on this drug of Zoom meetings and video conferences, right?
Mm-hmm. Mm-hmm.
But that's not where I'm going. While that may be a strategic reason, I'm more focused on the tactical. And the tactical is this.
Mm-hmm.
Given that our core mobility markets are going to take a couple of years to recover, that couple of years, if we as an industry use it right, we can use it to help catch up on the terminal side of it, the remote terminal side of it, and the ground infrastructure side of it, with where the new space constellation thinking is. And that's powerful because all of a sudden, right, if you have all of your pieces ready at the same time, well, that's an AT&T network and an iPhone, right? The two things you need, the components you need to make the market grow, to enable a market to move.
Right.
So when you think of our industry, Virgil, and hey, you and I have been doing this for a while.
Mm-hmm.
In my opinion, I haven't seen a time where the big innovation step, where all of the inputs to make that great leap are as right as they are now.
Right. Yeah, that's really a very good picture, Carl. And now talk about your NXTCOMM. Given that what you just said, where are you at in your development of the phase array antenna, flat panel antenna?
So where we are in terms of, I like to look at this in two distinct portions: the development of the technology and the development of the products.
Mm-hmm.
We've completed our technology development phase, right? We've gone through all of the design. We're in the technology validation phase now, and that means we're building prototypes, rigorously testing those, both for RF performance and all of the other niceties in terms of mechanical and environmental consideration. And then we'll iterate through those through probably the end of this year, beginning of the first quarter.
Mm-hmm.
And then we'll be in the position to start packaging this all together as a product.
Right. So what's your target?
Our initial product in the market, or the first version that'll go through this phase, will be our KU band product.
Mm-hmm.
And that one's roughly about a 50 centimeter panel.
Mm-hmm.
and that, like I mentioned, should be ready Q1 of 2021.
Mm-hmm.
And then we have a parallel project with a Ka-band version that's about 6 months behind.
Mm-hmm. Now, those are for maritime and aero applications, or they can be used for
So
ground comms on the move too.
yeah. So from a technology perspective, our products and the design of our products are agnostic to application, right? What we've done on the component level, when I talk about component level, I mean what we refer to as our basic building block of Legos, our subarray.
Mm-hmm.
And a subarray, just to give you some sense of what that is about a 25 centimeter by 25 centimeter panel.
Mm-hmm.
And then you click 4 of them together to make a 50 by 50, for example. So in the development of the subarrays, we've taken the approach of applying the most stringent the use case requirements to the subarray.
Mm-hmm.
And probably no surprise to you when I say that, the most stringent in terms of the environmental and electrical considerations from the mobility use cases are mostly the aviation.
Right.
So we've taken this approach where we build the product to the most rigorous, the component to the most rigorous standard. And then it gives me the flexibility to take a subarray or a collection of subarrays and put them in a package of productizing for the aeronautical market, or taking those, putting them in a package fit for purpose on a boat, or on the top of a car, or some kind of terrestrial mobility case.
For trains or buses or
Exactly.
Yeah.
Exactly.
Right.
Anything with wheels, tracked or not.
Right. What about for the LEOs? What are you doing for the new LEO constellation?
So in our design criteria, even today, all of what we're doing is LEO capable. It's a tough statement to make because there's so many variations and differences among all of the LEO constellations, but we spent a lot of time doing our homework. So we're pretty confident that from the core, I mean, starting with the frequency band, right? From there, that the products we'll deliver into market, the technology we're developing will be capable of being used on LEOs and supporting the multiple satellites at the same time, handoff or make before break.
Right.
Even where we are now, we've designed LEO interoperability and LEO use into our technology. The products will be able to support multiple target satellites communicating to 2 satellites, for example, simultaneously from the very first product iteration. And then we'll go ahead and improve those as the LEO constellations get closer and closer to in-service date.
Right. So going back again to that issue of the price point, a lot of the skeptics about the LEO, the upcoming LEO constellations is that it's really on the ground, the cost of the ground terminals. It has to be really, really low because it has to go to developing countries, where ARPUs are kind of lower than in industrialized countries. So how are you solving that? And then do you think you'll be successful in meeting those price points, which are very, very aggressive?
Yeah, well, the price points are very aggressive, absolutely. Honestly, it's the biggest single challenge in any new technology development, right? Again, going back to my terrible mobile phone example. When the iPhone launched, 13, 14 years ago,
right,
it was not done in a way that made it compelling to the average consumer in developing countries. The price tag was still too high. And yet today, smartphones are being sold at price points that are compelling to the average consumer, even in developing countries, right?
Mm-hmm.
So the reason I say that, it's important to prove the technology. And by starting in some of the less price-sensitive markets, in particular, the high-value mobility markets. And by high value, I don't mean high dollars. I mean where the benefit of an electronically steered antenna, a flat panel antenna, has economic impact or high value to the end user, right?
Mm-hmm.
Like, let's face it, you can't fit a 1 meter parabolic on top of a Humvee.
Right.
Well, with any level of scale, right?
Right. Right.
Likewise, you can't fit a 1 meter parabolic on even a commercial aircraft.
Right.
So I picked on those markets on purpose because there's a compelling value proposition for the flat, the multiple target satellites, all of these benefits that the NXTCOMM antenna brings to market in those market niches or market verticals, right, that are less price sensitive. So you can develop your product there. You can learn the lessons from having having the experiences in those markets, and then the run like hell on the other side of it is implementing those to reduce your cost.
Right.
Now, fundamentally, going back to my example of NXTCOMM's antenna approach being that of a printed circuit board or a PCB, one of the biggest single drivers in cost of electronics is the volume.
Right.
Right. If I'm buying components to build 10 antennas, for example, or if I'm buying components to build 10 million antennas, the price per component is significantly different. Same through the manufacturing process. One of the things that our industry has struggled with in adopting more of these manufacturing processes from ancillary telecom industries is that we just don't have the scale to make it interesting, right? We can go to a contract manufacturer, an electronics manufacturer around the world and tell them, hey, I'm going to make a high volume of satellite antennas this year. Right. And this guy or this company on their line, they're making, say, I don't know, Samsung phones. Oh, great. How many? Oh, if everything goes well, we're going to sell 20,000 this year. This guy's going, great. I ran off 20,000 mobile phones in the last 2 hours on my smallest line. We need the scale, and this is what I keep saying. It's crawl, walk, run. But the important part is that the underlying technology that you're implementing has to be scalable to those stupid volumes, to those volumes that we just don't have a comfort level with now.
Right.
I mean, and in that respect, I have to give some credit to the likes of Hughes or Viasat. Think of what they've done. They're reaching hundreds of thousands, millions of residential subscribers today.
Right.
And it wasn't so very long ago that those guys at Hughes and those guys at Viasat were thought crazy by the rest of our industry for, there's no way they can get a residential VSAT antenna with a buck and an LNB, blah, 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 sub $1,000.
Yeah.
And both of them did it quite well.
Right.
Now, I say that just because it's a little bit of the theme that we were discussing in the SSPI presentation. But have we as an industry lost our imagination? Would we rather be the guys that say, oh, it's never going to happen, to defend our own position? Or is it time to suspend our own disbelief and work towards a big goal?
Right, right. So thank you very much, Carl.
The pleasure's been all mine, Virgil. I really appreciate the chat.
Thank you. Thank you. And for all the news and information on the global satellite industry, you always have Satellite Markets and Research at www.satellitemarkets.com. And this podcast is also available on our YouTube channel, which is the Satellite Market Casts. And you can listen to interviews of other executives, both video and audio interviews of other satellite industry executives.